What's up, everyone? Welcome back. Let's build some code intuition. So, today we have with problem number 3622, check divisibility by digit sum and product. As the problem name suggests, the solution lies and it's very simple. So, it's like basically rated as easy problem. Uh, it is like check divisibility by digit sum and product, that is digit product. So you will be like you have to find first the digit sum of n. You will be given a number n where you have to find the digit sum and then also the digit product, and at last you have to add them in sum, and you have to just check that if n is divisible by sum or not. That's it. So moving to example you have here, I will show you one example here too, so for better understanding. If n is equal to 99, so we know the digits are 9, comma 9, the first 9 and second 9. So the sum becomes 9 plus 9, that is 18, and the product becomes 9 into 9, that is 81. So what you have to do, you have to basically add it in sum and then check its divisibility. So adding these two, that gives us 99, that is sum of digits plus product of digits. So 99, then check if it is divisible by n. So 99 modulo 99, if it is 0, that becomes true. So we have to return true in this case, else we have to return false. So this is like the problem what we are solving. So we can be moving, or just the thing is we have to go with digit by digit scanning and then add and product them and then at last sum them. So let's move to the digit extraction trick. So that's and very simple, where we use the modulo operator to fetch the last digit. So let's consider this 95. If we want the last digit, what we do? Just modulo it by 10. So when we modulo it by 10, we get a remainder. So when 95 will be divided by 10, 90 will be properly cut and the 5 will be the remainder. So as 5 will be the last digit. So once you get the last digit, you divide the number with 10. So when now in case 95, you divide it by 10, you will get 9.5. When we convert it to integers, we will get 9. So we can understand that when we divide a number by 10, we remove the last digit, and when we modulo it, we get the last digit. So using this logic, we can move or iterate it until the while loop at until we get n is equal to 0. Now in consider in this case, now here we get n is equal to like 9 when we divide it. Now when one more time we will divide it by 10, 9 divided by 10 is 0.9. When we convert it to proper integer, we will get 0. So the stopping condition will be 0, and that is n is equal to 0. This is the one loop which we can run, and that will be an enough. So let's move to the code directly. I have been made two integers, that is digit sum, that is initialized with 0, because we know for sum we initialize it with 0, and digit product I have initialized with 1 because we have to multiply numbers, and if so it is initialized with 1. Now I have used int copy. Why copy and not directly n? Because I am going to like divide the number by 10, and at last it will become 0. That will be the condition of breaking this loop. So if I lose the value of n here, I cannot, like, at last I will check that if n is divisible by sum or not. So for that I have like made this copy, and then I have made all the operations on copy, and I have not changed the value of n. So that is the whole logic which I have explained here, that is in the digit extraction trick. This is the logic, that is digit sum is the sum of the last digit. I have added digits by digit, and product is also the multiplication of the previous product with the last digit. So one by one, when we finish off all the digits, we get the number, or the all the digits in it. So this is the, and at last copy divided or equal to 10, so that we move to the remaining digits and remove the last digit with it. So this is like the whole loop, and when we finish off this loop, we get the value of SNP, which was basically this SNP. Now once we get the value of SNP, we have to add them. So I have made an integer sum with digit sum plus digit product, which we have calculated here, and at last just check if it can directly or perfectly divide n. If it is, it will return true because I am checking this condition. If it does not, it will return false. So this was the whole the code, and it performs significantly well as it bits 100% of the codes. So this was the whole. Let's move to the complexities. What is the complexity? So as in the constraints, it is mentioned that the number is strictly between 1 to 10 to the power 6. So maximum the number of digits will be 7, and this loop, this one, will run till total number of digits. So if looking it, the digit will like, or the number of digits will be maximum 7, minimum 1. So effectively that becomes our time complexity becomes big of 1, that is constant, and space complexity is also constant, as just we have made integers, that is this 3 integers and this 1. So there are in short just 4 integers, so it is also constant. So we have, this is like a very good solution where both the time and space complexities are in big of 1, and that's was the whole solution, and it also performed well. So that's for it today. Keep building the intuition, and I will catch you up in the next one.